Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the medium type problem of the LeetCode. And here you can see its name is array nesting. Its index is 565. Okay, so before moving on, the tags associated with this problem is like you can have a brute force approach or you can have a depth first search approach, and this problem basically involves the simple or prerequisite knowledge of basic maths. Okay, so what you are going to do is like we need to mark the array elements being visited, and this can be easily done if you are aware about the concepts of graph theory and how to make the directed edges and so on. We will discuss all that in this video. For now, let's discuss this problem and then we will together move on to the best solution for this problem. So we will be given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. So every element in the every element in our array will be ranging from 0 to n minus 1, and it is basically a permutation of first and whole numbers. And what we are going to do is like we are going to build a set sk which is going to satisfy this relation. You can see here a mathematical relation that is being given to us. We would be simplifying this mathematical relation and we would be deducing some basic concepts from this. For now, let's move on further. I will explain this entire term later on with the help of examples in this video. Okay, so you need not to worry about. And there are following rules also. That is the first element in sk. You can see the nums of k starts with the selection of the elements nums of k exactly equal to for any index k. That is, we can start from any index k, and we'll stop adding right before a duplicate element occurs in this set. Okay, so we'll be extending this set till and then until we are going to have a duplicate element that is being already existed in our set. Okay, so I will discuss all that. For now, let's move on. Return the length of longest length of a set sk. That is, what is the maximum length of this set that we can build. We need to find out that. Okay, you can see the constraints is like nums of length is around 10 raised to the power 5. So we would be like having the O of n type solution or O of n log n solution. You can see O of n square solution is not going to pass. So the very first thing is like we would be thinking for the best solution, that is O of n time, and O of 1 space solution. You can also have O of n time and O of n space solution also. And all the values of nums are going to be unique because we to the permutation of first and whole numbers. Okay, so let's move on to discuss this problem with the help of examples. Then we will together build up the best solution for this problem. So let's move forward. Okay, so you can see the mathematical relation is like nums of I. So let's say nums of k, and the next element is only going to be builded up only and only when we are going to fetch write down this as nums of I1. Let's call it as I1, and you can see that I1 is basically, according to this problem, is like this value. Okay, so if this value is I1, we are going to find out the next element as nums of I1, and let's call this as I2. Then in the next element will be called as nums of I2. Okay, so the only tricky point that is being noticed over here is like if we call the current element as x, then this x can only be made or can only be find out if we know the value of this previous element. Okay, and the thing that you should focus upon is like whenever you are trying to find a new element, let's call now as y, then this y should not occur for all those previous values present in our current set. It means that this set will always contain the distinct elements. Okay, so for analyzing this problem, for analyzing this mathematical relation in detail, let's move on by taking an example. Consider this as the set that is being given to us. If we write down the indexing for this one, 0, 1, 2, 3, 4, 5, 6. Now you can find out the answers in O of n square time. Start from any of the index. You can see that the problem statement says that nums of k, sk starts with the selection of the elements with index equal to k. That is, k can vary from 0 to n minus 1 any position. You can check out by iterating for every position and try to try to find out the new element until the duplicate element does not exist. So it will cost you an O of n square time, but we are not interested in that. We are going to have a O of n solution. Okay, so let's try to find out some new concept over here. Suppose we are going to start with this element 5. You can see if this element 5, new element is always going to exist from the previous element. So previous value is 5. then we are going to have the current value as nums of 5. So this value, that is 6. So if the previous element is 6 right now, we can fetch the current element by fetching the previous, by treating the previous element at the index. So you can see that the current element will be nums of 6, which is 2 over here. Okay, so this will be 2. Now if the previous element is 2, my current element will be nums of 2, that is this one, 0. So if it is 0, now current element is 5. But you can see that now our iteration stops. So because the 5 is going to already existed over here. So what we are going to do now, we are going to make this happen like this one, from 0 to 5. Okay, now according to this problem statement, that you can see this edge, like I have built some arrows over here. Let's call it as directed edge in a graph. Why I'm calling it as a directed edge in this graph? Because when you try to reach the value 2, you can see that you can always reach the value 2 only and only when from 6. And if you try to reach 6, it can always be done from the 5. Okay, now consider the case like as I've already said, you are going to start from every index. Let's call index equal to k and check it out what is the maximum size of the set, but that will cost a O of n square time, right? So we need to optimize our code. How we are going to do that? Now consider this case, like if we start from 5, you are going to have a maximum size of set as 4, from 5 to 6, 6 to 2, and 2 to 0, and now again to 5. So this is not possible. Maximum size of set is 4. Now consider the case like when we are starting from the 6 right now. Like previously I've done for 5. Now consider the case like I'm starting from 6 now. So if I will start from 6 now, so then the next element is 2, next element is 0, the next element is 5, and next comes 6. It means that again the size of set is coming out to be 4. And similarly, if I will start from 2, again the size of the set will come out to be 4. If we start from 0, size of the set will come out to be 4. Okay, so no need to iterate for every element, right? So we are going to iterate for a single element that is going to lie in a particular connected component. You can see that these all the elements are lying in a same connected component in a directed graph. 5 to 6, 6 to 2, 2 to 0, and 0 to 5. There is a cycle in this graph. It means that if you start from any of the element, you are going to end up to that element which is lying in the same connected component. So rather than doing for every element in this connected component, we are going to do for a single element and find out the size of the maximum, like we are going to find out the what is the size of this current connected component, which is the maximum size of the set. Let's call it as s. But you can see that this element is not going to include all those elements lying in this array. So we need to do for the more elements, like you can see that the one is not included. So from 1, I need to go from nums of 1, which is 4. And from 4, I am going back to again to this one. You can see that there is a cycle already found. It means that from any of the elements, either from 1 or 4, if I will start, like start our building the set, you are going to end up with a maximum size of 2 because these all are lying in the same connected component. And what about the 3? You can see that if I will start from 3, I'm going to nums of 3 back again. It is a connected component of size 1. So the maximum size of the set is going to be 1. Okay. So in other words, you can understand this problem as build a directed edge for every nums of I that is lying in this array. And the directed edge is going to start from nums of I, that is if I'm at ith index, and it will go to the direction to nums of I. So the directed edge will be like this one. Okay. So like you need to find out the all size of the connected components, all the connected components that is going to lie in this graph, and you need to maximize your answer with the size of the connected components. So this will be your answer. So let's move on to the coding part to analyze this problem in detail. Also, I am going to provide the alternative solution of this one without considering the graph theory concepts. Okay, so let's move further. Okay, so you can see that I've already submitted the solution. So let's first talk about the graph theory solution, like by building the directed edges. Then we are going to talk about the simple basic maths approach. What I've done is like make an adjacency list and push back the directed edge like this one. Num suffice the current edge where the directed edge is going to start. Like it has the out degree and the edge that is going to be inserted, like the node that is going to be inserted, like nums of 5 is going to hold the in degree. Okay, that is in degree will be incremented by 1. So this is the directed edge, and I'm going to push back into the adjacency list. Now there is a visited vector also, and I'm going to iterate for every I and check that if it is not visited, I'm going to perform a depth first search operation. And in the depth first search operation, you can see I'm always going to end my depth first search traversal when we are going to find already a visited node, because in this case you can see what I've done is like I'm going to call the child node of this current node only and only when if it is not visited. Okay, suppose that we have this iteration like when we start from the 5. Okay, when we start from the 5 in the depth first search, I'm going to 6, and then again we are going to 2, and again we are going to 0. And now if I'm again going to 5, you can see that this is not possible because this is already visited. So it means that I'm going to have the size of the connected component as 4. And in each case, you can see whenever I'm going to visit a non-visited node, I'm going to increment my count as increment my count by 1. So this will give us the size of the connected components. So after the traversal of every connected component, I'm going to have the size of the connected component in count variable. I'm going to maximize our answer like this one, and I'm going to print the maximum answer also. Note that the time complexity of this approach is like O of n, because we are visiting every node at most 2 times, I think, yeah. So like O of n, like this is for O of n, and for every time I'm going to visit this one again. Like we cannot have O of n squared solution because every time we are visiting the nodes 2 times. So O of n plus O of n, which is O of n, yeah. So and the space complexity is also like O of n. Okay, so let's talk about the simple math solution. What I am going to do is like start with the every index, you can see, and like index starts with 0 and goes up to nums dot size. And whenever we are going to visit a particular node, we are going to mark that node as visited, right? Because if we are not going to do that, we are going to visit that again, which is not going to be possible. Okay, so what I've done is like whenever I'm going to visit a particular node or let's say particular array value, we are going to change the value at that index with the maximum value. You can see I've changed that value to nums dot size. You can also make it that negative or any value except the values that is being given to our in the problem statement. Like we have the values from 0 to nums dot length. So we are going to make like mark the current node value as visited, and we can assign any value either negative or greater than equal to nums dot length. Okay, so what I've done is like while nums dot j is not equal to nums dot size, while next node is still not found, which is visited. Sorry, while we are going to do this iteration till and until when we are going to find the next node which is being already visited. You can see I'm going to implement my current. It is going to store the current answer and find out the current value, and make this value nums of j as the maximum value, which is going to denote that this node, or you can say this index, is already visited, and assign j as this is the previous value, which is nums of j, so that we can move to the further indexes. And if this all goes done, like we have found that index, or you can we have found that node which has already been visited, our iteration stops, and we're going to maximize our answer. Note that you need to increment your index also, like we are going to also move on to the next one. And note that this while loop is always going to run only and only when this condition holds. Okay, suppose that for a particular node which is already being visited, and the index reaches to that value, let's say index equal to 2 is already visited, right? And now again when this index start with 0 and goes up to 2, the nums of j is already visited, so this value will not this value will not run even a single time. Okay, so in that case also, like the time complexity is around O of n, like it is exactly O of n, right? And the space complexity is around O of 1, and this will give you the correct answers. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask you to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.